I'm Margherita Crosta and I'm working at CREA, which is the Italian Council for Agricultural Research and Economics. And it's about 4 years that I work there in the center based in Lodi and studying breeding applied to legume crops. My studies are in agricultural sciences, and I just finished a PhD about genomic selection application to pea breeding to improve grain yield and protein content in Italian environments. I'm involved in the BELIS project with activities especially on pea and white lupin. And my role is both in the development of and validation of genomic selection models for traits of interest, and in trying to integrate molecular markers in the variety distinctness assessment trials. So the theme would be the possibilities for integration of molecular markers in the varieties distinctness assessment. And I think this is a very interesting topic in perspective, because for the way they are structured now, these trials are really demanding in terms of time and cost. And so I think integrating molecular markers in a way that is effective can really contribute to fasten the release of new varieties, and so help farmers facing the new challenges, for example, of climate change. And yes, I will be really interested in hearing the talks of the other speakers, and I hope that my talk can be of interest in this sense. So we are acting mainly on two sides. So due to climate change, there is an increasing unpredictability of weather conditions. And this is especially true for pea, that is a crop that is especially interesting, especially in the Mediterranean area for autumn sowing. And autumn sowing, it's interesting because we can avoid drought stress at the end of the season, but we need varieties that are frost tolerant, and this is one of the goals of our activities in BELIS. So we will develop a genomic selection model to predict pea genotype frost tolerance. And at the beginning, we will collect the data in a freezing chamber, so under controlled conditions, but then we will also try to validate this data with the data coming from the field, so a more real-life scenario. And I think this will be a very useful link between the lab data and the real life. And we will also try to go a little bit more in detail, for example, with genomic association studies to try to identify eventual genes that have a big effect on this frost tolerance. And we will also work the other way around. So if we cannot, for some reason, sow during autumn, then our varieties should be resistant to drought. And anyway, even if we use autumn sowing, they should be, because during our summers we see increased drought levels even in unpredicted periods. And so this is the other aspect we are working a lot in BELIS. So try to develop genomic selection models to select varieties that are drought tolerant. And we will also as well go in more detail with association studies to identify eventual genes that are important. But I think especially genomic selection is a very useful instrument here, because drought tolerance normally depends on many plant characteristics, and genomic selection is something that can really encompass all these characteristics and summarize them in a model. And so I think this will be very helpful. Yes, I think BELIS will be crucial to increase the sustainability of legume cultivation. So legume cultivation is very important in this period because legumes have the capacity to fix nitrogen in soil. And so this way we can reduce the use of nitrogen fertilizers that are produced through a very energy costly process. And so we can reduce in the end the greenhouse gas emissions, which is a bit what we all want to achieve. And especially I think this project has a great potential in linking the research and academic world to the farmer industry and more practical world. And so I think it has a great potential in this sense to act as a connection, because sometimes we have at the academic level we already have some useful tools that are not used in everyday life because of this missing linkage. So